Today we will learn how to determine the position of an element in the periodic table. That is the determination of period, group and block number of an element in the periodic table. For that, let us see the periodic table first. You know very well that there is 118 elements up to date, and do you think it is very easy to remember the position of all these elements in the periodic table? But it is very important to know the position of the periodic table of these elements. So how we will determine these numbers, like how we will determine the block number or the period number or the group number. So there is a process that we have to learn. For that, first of all, we will write the electronic configuration of the element, and writing this electronic configuration correctly is very much important to know the position of these elements in the periodic table. And while writing that, we should remember that we are not going to write the electronic configuration considering the half filled or full filled electronic configuration. That is, for chromium, whose atomic number is 24, we will be writing the electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. But actually we write it as 4s1, 3d5 because we know that 3d5 is the stable electronic configuration as it is a half filled configuration. But we will write it as 4s2, 3d4 here. Now, first we will determine the block of any elements. That means in which block, S, P or D or F it belongs. For knowing that, we need to know the subcell where the last electron enters. So we will look at the electronic configuration and we will determine that. Like for chromium, you have seen the electronic configuration is argon, then 4s2, 3d4. The last electron has entered in the d orbital because 4s orbital has been filled before the d orbital. So the block will be obviously d block. Now we will determine the period number. So period number will be determined by the highest value of the cell present in electronic configuration. So again, in chromium you see it's argon, then 4s2, then 3d4. So what is the highest value of cell present here? It is 4. This is the highest principal quantum number present in the electronic configuration. So the period of chromium will be period 4 in the periodic table. Now we have to determine the group number. So for determining the group number, there are few rules. Like for S block elements, it will be the number of valence shell electrons. Like let us consider lithium. Lithium has atomic number 3 and its configuration is helium, then 2s1. So what is the number of valence shell electrons present here? It is 1. So the group number for lithium will be 1. Now let us consider a p block element. For p block element, the group number will be 10 plus number of valence shell electron. So we know chlorine. Chlorine is a p block element and its atomic number is 17. So what will be its electronic configuration? It will be neon, then 3s2, 3p5. So what will be the group number? Group number will be 10 plus 2 plus 5. So that is 17. So chlorine belongs to group 17. Now for a d block element, it is the number of electrons in n-1 d cell plus nth cell. So let us consider zinc. Zinc has atomic number 30 and its electronic configuration is argon, then 4s2, 3d10. So what will be its group number? Its group number will be n-1 d cell number of electron is 2 and in nth cell number of electron is 10. So the group number will be 10 plus 2, that is 12. So these are the rules to determine the position of any element in the periodic table. We'll go for some other examples as well. Like you see sodium. Sodium has atomic number 11 and its electronic configuration is 1s2, 2s2, 2p6 and 3s1. So how we will determine the block number, period number and group number for sodium? First we will look here, and here you can see it's the last electron has entered in the s orbital. So obviously sodium will be in the s block. Now what will be the period number? The principal quantum number, the highest number present here is 3. So it will be in period 3. And what will be the group number? Group number for s block element, we know it is the number of valence electrons. So it is 1. So sodium will be in group 1. Now for a p block element like aluminium, let us first write the electronic configuration, and its atomic number is 13. So the electronic configuration will be 1s2, 2s2, 2p6, 3s2 and 3p1. So what will be its block? Obviously it will be p. Then what will be its period? Period will be 3. And now what will be its group number? Group number will be 10 plus 2 plus 1. So what will be that? 10 plus 2 plus 1 is 13. And you know how this 10 has come? I should explain you. Here you see these are the p block elements and these are the d block elements. In the d block elements we have already filled up 10 electrons. Then this p block comes. That's why here one additional 10 is incorporated while calculating the group number. Now for one d block element like copper, the atomic number is 29 and its electronic configuration will be obviously 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d9. Now if it is 4s2, 3d9, it will be obviously in d block because the last electron has entered in d orbital. Now what will be the period number? Period number will be 4 as the highest principal quantum number present here is 4. Now what will be its group number? Group number will be the number of electrons present in s and d orbital. That is 9 plus 2 is equal to 11. So students, in this class we have learned how we can determine the position of any element in the periodic table. You can take any element, and if you know the atomic number of that element, you will be obviously able to tell its position in the periodic table. So for today we are going to finish my lecture, and in the next class I will see you and we will discuss about the effective nuclear charge. Thank you.